Hello, I'm Sahil Prashar, and welcome to my project, Data-Driven Discovery, Coronavirus Analysis with PostgreSQL. During my Mentorness internship, I used PostgreSQL to analyze coronavirus data, developing efficient data loading strategies and optimizing database queries to extract valuable insights. Let's dive in. This is the task 2 of the Mentorness internship program focuses on the COVID-19 pandemic, a global health crisis affecting millions. Data analysis is crucial for understanding the virus's spread, identifying trends, and informing public health decisions. The task uses PostgreSQL to examine key aspects of the pandemic, providing insights into its impact. These are the 4 key objectives of the presentation. First one is data exploration. We will explore the coronavirus dataset to understand the structure and content of the data. Second one is SQL proficiency. We will demonstrate proficiency in writing SQL queries to extract insights from the dataset. Third one is data analysis. In this we identify uncovered trends, patterns, and correlations within the data to deepen our understanding of the pandemic's dynamics. Fourth one is insight generation. We draw meaningful conclusions and actionable recommendations from the data analysis. These are my goals of the task. First, gain insights. In this we extract meaningful patterns and trends from the dataset to better understand the pandemic spread and impact. Second one is identify hotspots. We will determine the countries or regions with the highest number of confirmed cases, deaths, and recoveries. Third is analyze trends. We will examine the dataset to identify changes in the pandemic spread over time, including increases, decreases, and plateaus. And the fourth one is inform policy. Provide data-driven recommendations to inform public health policy and decision-making. These are the steps for importing data into PostgreSQL, a step-by-step guide. In PostgreSQL, we need to create a database. In a database, we have to use the query tool to create a table for our dataset. As we can see on the slide, we can give names to whatever we want. But we need to be careful when we are creating tables, like when we have to use text, float, date, and integer. In PostgreSQL, we are using text with alphabets. And we are using an integer with a whole number. With decimal numbers, we are using a float. After creating our table, we can check if our code is running or not. Like I mentioned in this slide, after that, select the table as we can in this slide and go on Import, Export Data. From there, we can import or export our data in different formats. Like we can see in this slide. Suppose we have already created a database. In that case, we have to directly go to the database and select the table where we want to import our dataset. After that, go on to import and export data, like I already explained in the previous slide. So you can directly import or export our data in different formats. Now let's begin with questions. In the first question, we need to check if any null values are present in our dataset. So in this question, we are using null for checking the null values. So as a result, our dataset does not contain any null values. In question second, we have to use the update statement for all columns where the recovered, confirmed deaths, and null values are present to zeros. Also, we have to use SQL's coalesce function returns the first non-null value from a list of expressions. If confirmed is null, it returns 0. Otherwise, it returns the value in the confirmed column. As a result, our dataset does not contain any null values. In question 3, we have to use count function to get the how many rows contain our dataset. Like I use the count function. Add the result is 78,386. In question 4, we need to find the start and end dates of our dataset. So we apply the min function to the start_date column and alias it as start date, and likewise, we apply the max function to the end_date column and alias it as end date. In question 5, we are using month function. In SQL extracts the month component from a date value, allowing you to isolate and work with the month separately. In question 6, we are using the year function, which extracts the year from a date value. The AVG function calculates the average value in a column or result set. We are finding the monthly average for confirmed deaths and recoveries, and the result we can see on the slide. In question 7, we need to find the most frequent value for confirmed deaths and recoveries each month. So we are using the SQL_stringagg function as an aggregate function that is used to concatenate the string values. And the SPLITPART function is used to split a string from a specific delimiter, and these queries return the not substring. In question 8, we have to find minimum values for confirmed deaths and recoveries per year. We are using the min function returns the smallest value of the selected column. In question 9, we have to find the maximum values of confirmed deaths and recoveries per year. So we have to use the max function returns the largest value of the selected column. In question 10, we have to find the total number of confirmed cases, deaths, and recoveries each month. So we can use the sum function returns the total sum of a numeric column. And the AS keyword renames a column or expression in a SQL query. In question 11, we have to check how the coronavirus spread out with respect to the confirmed case. In this, we can use the variance function calculates the spread of data in a column or result set. And the STDEV function calculates the statistical standard deviation of the field's numerical values in a particular column. In question 12, we have to check how the coronavirus spreads with respect to the number of deaths per month. In this, we are using the month function, which returns the month part for a specified date, a number from 1 to 12. In question 13, we have to check how the coronavirus spread out with respect to the recovered case. In this, we are examining the data in relation to the number of cases that have recovered. In question 14, we are finding the country with the highest number of confirmed cases. In this, we need to specify the column of interest, and compute the total, and rename the result as total, using the AS keyword. Also, we have to use the limit clause to specify the number of records to return. So we can see in this slide that the US has the highest number of confirmed cases, along with India, Brazil, France, and Turkey. In question 15, we are finding country with the lowest number of death cases. In this question, we are using the USH command as used to sort the data returned in ascending order. In question 16, we are finding the top 5 countries with the highest recovered cases. So we have to retrieve the top 5 countries with the highest recovery cases using limit 5. The results show India has the highest recovered cases, along with Brazil, the US, Turkey, and Russia. In this slide we talked about COVID-19 dataset analysis, trends, insights, and country-wise impact. First one is data completeness and quality. First, let's take a look at the dataset's completeness. We've ensured that all essential columns have no missing values, and we've replaced any null values with zeros for consistency. Second is temporal analysis. Now, let's visualize the data over time. We've calculated monthly averages for confirmed cases, deaths, and recoveries, giving us a clear picture of the trends. Third is statistical analysis. Let's dive deeper into the statistics. We've identified the most frequent values for confirmed cases, deaths, and recoveries each month, highlighting the typical situation. We've also calculated minimum and maximum values per year, showing the range of values. Fourth is country-wise analysis. Now, let's explore the country-wise analysis. We've identified the top countries with the highest number of confirmed cases, the lowest number of death cases, and the top 5 countries with the highest number of recovered cases. And the last one is spread and impact analysis. Finally, let's analyze the spread and impact of the virus. We've calculated total confirmed cases, average, variance, and standard deviation, giving us a comprehensive understanding of the virus's spread. We've also visualized death cases per month and recovered cases per month, showing the severity and recovery trends. In this slide, we conclude the presentation. Our analysis of the COVID-19 dataset revealed key trends, patterns, and country-wise differences in cases, deaths, and recoveries. Data quality, completeness, and consistency are crucial for understanding the pandemic's spread and impact. Data analysis informs public health decisions and strategies to combat the virus. The findings have implications for policymakers, healthcare professionals, and individuals worldwide. Data-driven decision-making is essential for building a healthier, safer future. Thank you.